Hello and welcome. I'm actually in high spirits because today we get to do one of my favorite topics. Now, the thing that I love about loading OBJ models, why does it have to be OBJ models? It's because the OBJ model format is very text readable and it's a great exercise for intermediate programmers, not just from a graphics perspective, but just from a programming perspective. So if you remember the Marauder from Doom Eternal, people hated it. But then when people understood the skills and the strategies, some people actually came to love it, all right? So if you're thinking about loading OBJ models and you're feeling intimidated, just think about the Doom Marauder, all right? It's a challenge, but we're going to get through it. It's going to be a lot of fun. So what I'll do is, I think I'm done showing off my background. I'll just open this up. Where are we? OpenGL. Okay. You'll open in the GitHub repo the start folder and go from there. But I just want to give you an idea of what we have to start with. So we've got this girl model. Now, if you've looked at any of my other tutorials, you know I sort of like loading in girl models, not in a weird way, but just from an artistic perspective. Looking at the feminine form is just nice to look at. Hey, maybe that's me, maybe that's weird, I'll stop talking. So, how do these OBJ things work? Oh, there we go. Text editor works just fine. So, if we look through here, we have some things, and not all of this is going to be relevant for us, but I'm going to talk through it anyway. So, we have this, that's really hard to read. Okay, this line below here, material library, girl.mtl. That's this other material file. We'll have a look at that later. Now we have this O line. This O line is defining an object, but for our purposes, that's fine because we're going to load everything in and all the objects are going to be stuck together. Totally fine. Then we have this V line. Okay, these V lines down here. And the format is they start with a V and then a space, and then there are 3 floating point numbers separated by spaces. And then, if we bring this down, come on. Okay, then we have these VT lines with 2 floats. And then we have these VN lines with 3 floats. And then finally, we have these F lines. And these F lines have a number of these little combo numbers. So these slashes in between, and there's 3 of them. Okay. And then, whoops. Oh, this is going to be hard. Okay. Wonder if I can. Okay. So then as you can see, after defining one object, we can go and define another object, and it works the same way. So we have the V, VT, and VN. Now, mysteries revealed. What does this mean? Well, V is for vertex, and these are X, Y, Z triples. These are 3D vectors, vec3s. VT is texture coordinates, vertex texture. And we have UV coordinates, so a vec2. And then VN is vertex normal. There we have it. And then right down here, this F stands for face. Now a face is, each of these is a corner, and that is a combination of a specific position, texture coordinate, and normal vector. Now this is a little weird because we know that if we get 3 corners, that makes a triangle, but then what's happening with this 4th corner? So that's something to think about too. So what I'm going to do just right now, actually, you know what? Before we get to that, I think it is important in these early cases just to literally look through all the files and just see what we have and talk a little bit, strategize about it. Okay, so this is the material file. This line says we have, I hate this formatting, this highlighting, that's fine. This line says we have 2 materials. We've defined a new material called eyelashes. We have all of these bits, these little properties, and then we have a new material called Lambert for Lambertian reflections or something like that. And for our purposes, we're going to completely ignore this. But in general, it is a good thing to be aware of, because sometimes we'll have cases in here with these faces where these middle numbers, the texture coordinates, are not present. You just have 2 slashes, empty space, no texture coordinates. Whoops. In that case, it's a good idea to be able to read in which color the object, the model, believes that triangle should be, if that makes sense. But I'm not going to worry about that. In this case, I'm trying to keep this video like nice and relatively short, but it is something to be aware of. Okay, so on to the actual stuff. Now I'm going to posit this to you as a little bit of a puzzle. What steps, given what we know now about OBJ models, the goal is to get all of this stuff into a just a big flat list of data. And don't worry about that so much right now. What steps do you think we should take to break this problem down so that we get reasonable code that deals with all of this? So have a think about that. Pause the video for a second. Are you back? Did you have a think about it? Okay, I'll stop being silly. All right, so there are many steps, but the first thing we're going to need to be able to do is we need to be able to take in a string for a single line of this file and split that into its individual components based on a pattern. So we could be splitting things based on spaces. We could also, for instance, be splitting things based on slashes in the case of these descriptions. So that's what I want to worry about first. So I'll just go back, open this up. Now I switched over to VS Code recently, and the reason for that is that I was using Codium, but Codium just doesn't have C++ syntax highlighting that works. Very strange. But anyway, so what I like to do is usually just delete the cache and reconfigure. Anyway, we're going through, treading over old ground here. So I'm going to define this function in my config stuff, in my config module. So I'll have the prototype here. So there we go. We take in a string that we want to split up. We take in a pattern that we want to use to separate the different tokens in the string. And then we collect all that and return a vector of those tokens. Okay, great. So now let's go ahead and define that. So we'll just head over to the source file. Okay, so far so good. Now the goal is to look through and find everywhere in this line where the delimiter pops up. So I'm going to store the position where the delimiter is found, and then everything in between the instances of the delimiter is the token. So in other words, if you had a sentence, the delimiter would be the spaces and the tokens would be the actual words. So I'm going to do something a little funky here. Now the funky thing I'm doing is I'm using this find function to find the delimiter in the line. I'm assigning that to a variable, and then I'm testing the value of that variable. Doing two things in one. Totally fine. So if the delimiter is not found anywhere in the line, that will return the end of string sentinel value, no problem. So what I want to do is extract the token. I'll do that by slicing from the start of the string up to the position where the delimiter was found. Okay, great. Then I will append that to the back of the vector. That's in there. Excellent. And now I will simply erase that from the front of the vector. So again, to go back to the analogy of a sentence, we have a sentence. All the words are separated by spaces. We find the first word, put it on our vector, and then remove that first word and the space from the sentence, And then in the next instance of the while loop, we'll keep checking through for all the remaining words. And this bit here is really important because this will, there we go, this will essentially remove not just the word that we took off, but also the delimiter itself. Okay, so this will work just fine, but there's one more case, and that is the case of the last word in the sentence, because the last word in the sentence may not necessarily have a space there. It may not necessarily be detected. So what we'll do is we'll just push on whatever is left. Whatever's left after removing is also a valid word. Okay, great. I'm pretty happy with that. So what I'll do is I'll just code up a quick little test. What you'll find in this session is it'll be pretty interactive, so I'll be writing code and then modifying it. Right, so currently our main function does nothing. That's totally fine. Okay, great. So this is almost the simplest case we can have. Start with a sentence, there we go. Log that out, great. And then iterate through the set of words that we get after splitting and print them out one at a time. Let's give that a shot. Ahaha, what have I done? It's come up multiple times. I used the wrong variable. There we go. Excellent. So we see we've printed out, this is a line, and we have split that into a set of words, and we're doing those one at a time. All right, so that being the case, let's get this test code out of the way. Remember back to those V, VTs, and VNs. Those were all cases where we had basically a vector. We wanted to read that off. So I guess the question is, how can we read a file line by line and then handle each of those vectors? Now there are a few bits involved here. One thing you'll notice if you look through this code is in the meantime I added this factory class, and the factory class will basically just make a bunch of things. So if I were to make a cube, making a cube in data-oriented design is a series of table inserts. You insert a position for the cube, you insert the cube's velocity somewhere else, you insert the cube's mesh somewhere else. It's all set up. And this factory will basically automate that with a little bit of internal state as well. Now, when we made the cube mesh, that was this line down here. I'm going to make another line. It's going to be void at the moment because I don't want to worry about building things yet. I just want to print stuff out. There we go. Yep. Make OBJ mesh and then go up here. There we go. We want a general function to make a girl as well. A girl. All right. So I'll just quickly code up a stub for this make girl function. I'll be reusing the make cube function. Okay, cool. Yeah, so all we need is really a position and a rotation. We'll set that up. All right, so we insert that position and rotation. Great. Now the girl is not going to be moving or spinning, so we won't have a physics component. But we will have this render thing. And what I'll do is I'll just sort of fudge it a little bit for now. So I'll say we'll make an OBJ mesh. And this will go through the work of reading the file. And I'll just populate this right now. I think this was star girl. There we go. Okay, so I'll just comment this out for now. There we go. Just comment this out for now. We'll worry about that later. But just so you can see, in the GitHub repo, I've also got this stargirl.png texture. This is essentially, it doesn't look like much now. Looks a bit scary actually, but this will be going on the model. Right. Okay, so the first task will basically be to open up the file, look through all those VT, Vn lines, and for each of those construct an appropriate vector and throw them in this set. Now that would be all well and good, but we can actually go one step better. We can read through the file twice. The first time we read through the file, we just count up how many of each of those vectors we expect, and then the second time we actually put them in. But we resize the vectors after we know how many to expect, and that avoids dynamic resizes, which is good. Just defining a few variables that I'll need. Line will be a placeholder holding the current line, and then we'll split that and put it into the words vector. There we go, cool. So hopefully you can see the strategy that I'm going with here. We have this file, open it up, we get its contents line by line, and then we close it. Okay, cool. Cool, so the way I think about comparing is sort of like every letter has a numeric representation. If we subtracted two things, I mean, it's not quite like that, but think of like subtracting strings. If you subtract two things and they're the same, then the result is 0. They're equal to each other. Their difference is 0, and that's why I'm putting this not in there. But basically what we're doing is we're just incrementing the appropriate variable. And it doesn't make a big difference, but there is some minor performance gain incrementing at the start, at least in theory. So by the end of this, we should now know how many of each of these things to expect. So we can now reserve some storage. Okay, so now I'm going to do exactly the same thing again. Or not quite. Okay, so the storage is reserved. Now I'm going to look through the file again, but now if I see that line, instead of just counting up, I'm actually going to extract the vector that I'm after. So I'll just head back to the header file, and I'm going to define two new functions. Great. And these are, right now, going to be pretty simple. You know, it just occurred to me I can probably bring this text size up a little to improve readability. All right, cool. So we just see that set of words. We construct the vector that we're after, and this case will be extremely similar. There we go, cool. So let's go ahead and use those. So if we see a vertex, we should get a vec3. And same thing for a normal, but in the case of a texture coordinate, we'll get a vec2. Done. And it really is that simple. So if we were to run this right now, well, first of all, it wouldn't do anything, but we'll address that in a second. What we can do, just to test, is, I'll just paste this in, is just check how many things are actually sitting in those vectors. So if we open the file and read it through properly and pushed all those vectors on, we should get some data. Okay, so let's go back and say, make a cube. Now let's make a girl. and I want that girl to be looking back at me basically, so spin it 100, whoops, wrong one, 180 degrees around the z-axis. Fingers crossed. Let's give that a go. Alright, took a second to load the file, that's fine, files are big. We can see down in the terminal that we've loaded some stuff. Also, forgot to mention this, but if you look, you'll see that I've also incorporated some normal data and done some really basic directional lighting, just for effect. It'll look cooler when the model's in, I promise. We've got that all set up. The next stage is, well, the next question is, all right, how do we deal with faces? So I wonder if this works. Models, girl. There we go, perfect. Okay, so in the previous bits, we're dealing with these Vs, VTs, and VNs, but now I need to deal with this face. And I'll talk about what's going on here. So this is actually, well, first of all, no, I'll say this other thing first. This is what's called an edge table, okay? So it's a description of a polygon, and these are the 4 corners of the polygon. So it's actually a quad, but we're going to build it from 2 triangles. My favorite method for building these things is to pick the first 3 points and say, okay, that makes a triangle. Then keep that first point and then pick 2 points after that. So I'm not sure if this makes sense. Let me illustrate this another way. So say for instance we had a set of points. Let's go 1, 2, 3, 4, 5, 6. We've got a 6-point polygon or something. So what I'd do is I'd say, let's pick points 1, 2, and 3. That'll make a triangle. And then pick points 1, 3, and 4. 1, 4, and 5. 1, 5, and 6. And yes, this is a union of triangles. They're all going to be connected because they all share a common point, and they'll cover this space. Now, the other thing I was going to say, but I stopped myself, it's really not such a big deal, is that these things, these numbers, are indices into the sets defined above, but here they're written around base 1, and what we really want to do is index them around base 0. So just subtract 1 from the index, but it's not something we're going to worry about right now. The next thing is, okay, how many triangles can we construct from this number of things? So if I look here, I have 1, 2, 3, that's 3 points, 1 triangle. Then if I go 1, 2, 3, 4, and that's 4 points, 2 triangles. Listen, I hope this makes sense. But the formula is the number of triangles for a face is the number of points minus 2. So bearing that in mind, I'm going to start modifying this code again. So I'll go right up the top, and in addition to this, I want a flattened, what are you doing there? Okay, I want a flattened layout, a flattened array for all of my data. Okay, this will be the actual vertex data, everything that gets loaded in. And I want to get the number of triangles that I expect. So I'll go down here and I'll say, alrighty, what will we do if we get a face line? Whoops. Well, we want to increment the number of triangles. And the amount we increment by is the number of, number of points defined minus 3. Why minus 3 and not minus 2? Because one of those words is the face, is the F. That's why I'm going minus 3. All right. Now we go down here and reserve. All right. So we have some number of triangles. Each of those triangles will have 3 corners, and each corner is going to have 8 floats, because we have 3 for the position, plus 2 for the texture coordinate, plus another 3 for the normal. So we reserve 24 floats per triangle. Okay, great. Now, what do we do? Yeah, what do you do if you see a face? Pretty much just call a function. Okay, so I'll just say read face. All right, so let's worry about that function. Okay, I know this is sort of a mess. I'll just bring this down. So yeah, great. Remember, the purpose of reading a face is essentially to build triangles. So for that reason, I'm going to pass in all of this state that I've been building up, as well as this vector that I want to throw my points into. Now, super important to note that I'm passing in references to these vectors because, well, I mean, it wouldn't really matter with this V and stuff because that's a read-only access, but it would be expensive to copy that over. So I want to pass by reference, not value. But in the case of vertices, it's super important because what if I'm building a bunch of triangles and I'm throwing them onto this vector of floats, and then back in my make mesh function, I try to upload that to the GPU, but I passed in this vertices by value, not reference. Well, then that vector that I built up just gets thrown away. Anyway, hopefully that's not belaboring the point. But yeah, let's make that function. Okay, cool. So we get the number of triangles we want to build, and then we start looping through those one triangle at a time. And then I think, okay, I want to read the triangles. I'm going to do that one corner at a time. So I'll read corner 1, and then, yeah. So if I equals 0, this is just going 1, 2, 3. When I equals 1, that 1 stays there, and the 2 and the 3 shift along. So that'll be achieving the same thing as I went through by hand, keeping the 1 and then drifting along through the vector. All right, so I mean, nothing satisfying is going to happen right now, but let's just run this check. We're not running into any errors. Nah, that's fine, but I just realized I forgot to actually call that function. So I'll just go. It's still not going to do anything, but it's just good to check. Yep, great, perfect. Okay, so we're almost at the stage where we'll actually have things rendering. That's always nice. Here I defined, or sort of set up that I want to read these things one corner at a time. So again, if I just bring up this file, these are the things I'm dealing with. Here I've got 4 corners. Each corner will really be a string, and that's, what am I thinking? Yeah, the string has got 3 components in it, and we want to fetch the VTs, VNs we defined above, and throw them into the vertices. So that's the basic idea. So I want to make a function which pretty much takes the same stuff, and we'll read a corner. Except that I'm just going to have a single string which is describing, it's the individual strings with the slashes. So I'm going to call that a description. Just so this makes sense, when I say description, I'm talking about this. So this bit here is one description. This next string with the slashes is another description, and so on. All right, cool. So we go ahead and split that based on the slash. That'll give us the individual indices. We will have to subtract 1 from each of them, but let's go through this. So we have position, So we'll be looking in the V vector, and the index there will be, we'll go string to long, first bit there, and then subtract 1. Now what have I done? VVT, VT. Well, you know, it happens. All right, cool. So now we want to flatten all that out, put that into the vertices. There we go. Excellent. Do the same thing for position, and I mean, it's not too exciting. I've already broken the problem down into its parts. We're just executing now. Okay, I think that's right. I think that's looking okay. Right, well then... Oh yeah. Okay. Looking good. Leg bone's connected to the shin bone. What is a leg bone? I don't know. Anyway, right, so what I'm saying is read corner works, and I think it's going to be called just fine here. And if not, we'll find out. We'll be the first to find out. Okay, so presumably by the time we get here and close the file, vertices has been filled up with all of the data that we need. If we were to look up at, make cube mesh, for instance, here vertices was hard-coded. It's all the data. So now I'm actually going to go ahead and grab the rest of this code. And go through it. Okay. So presuming that vertices has been set up correctly, we go ahead and create a vertex array object and a vertex, and bind that. Then we create a vertex buffer object, bind that as well. Great. Then we upload vertices to the, what am I thinking? To the GPU, to that buffer. Great. And then we enable and set up the attribute pointers for position, texture coordinates, and normal. Then we set up a render component. Now I modified the render component because now we're going to have all sorts of different models. They're not all going to have 36 points, 36 vertices. So to get the vertex count, I'm going to look at the size of things in vertices, and then it's 8 floats per vertex. So divide that by 8. And then I'm going to return that. Okay, great, no worries. So I'll just go and modify this bit so that it returns a render component, and up here as well. Alrighty, excellent. Can you feel it? We're getting closer. Okay, so back to this make girl function. What I want to do is call that function to give me a render component, and then in addition to the mesh, I'm going to set the material here, and then I'm going to push that onto the set of render components. In a future video, I'll probably look at this is a dodgy way of doing it, where I'm making a new mesh for every object in the game. We wouldn't do this. I'll fix this in future, but one step at a time. And we're only loading each thing once, so it should be fine. So let's give that a go and see what it looks like. I would not be surprised if there was a massive error. No, okay. There we go. Let's go. There's our goil. But there's a problem. There's a problem. And that is that it's just not loading the way I want it to. And that's totally fine. That's very common. As a matter of fact, Blender's default coordinate system isn't always going to match our project, and the coordinate systems that artists use, it's not always going to match the project. So I'm happy with this. By the way, this is what the model looks like close up. Little weird, little strange, but hey, there it is. What was I going to say? Okay, so the next thing we want to do is take in a pre-transform matrix so that we just apply a single transformation once on load and then get the model into our coordinate frame. Okay, so we're almost done. This will be the final stage. And to celebrate almost being done, I'm going to be a little bit lazy. And by that I mean I'm going to code and explain a little bit. Okay, so this bit will construct an identity matrix, and then I just want to throw on a bunch of rotations until it looks right. Okay, so this was found by experimentation. In practice, you load the model, change the transform, and just keep doing it until it looks right. Right, okay, so now what I'm going to do is throw that pre-transform in as an argument, and I'm going to have to modify this. So I'll go down to make object mesh, take that in as well. Now where this, I should probably, I'll go to the header. Sorry, I'm talking to myself. All right, so make obj mesh. So that's all well and good. Where this is going to be applied is when we're loading in the vec3s, because the vec3s are the positions and normals. They are going to get spun around, but the texture coordinates are not. So it's in this vec3 function. We'll take in the pre-transform, and what am I thinking? I'm also going to take in a W component. I will actually explain that. Jeez, I didn't, that spooked me. Control W? That's, function. Did you hear that? That's so loud. I jumped out of my skin. Okay. I hate that actually. That's freaky. All right. Anyway, that worked me up at least. So, what am I doing? We're going to take in pre-transform, and then we're going to go through all this stuff, and then pass in that pre-transform. Now, when I take in a position, I want to populate the fourth component of the vector with a 1. That means I can apply translation, should I wish to. On the other hand, when I apply a rotation, that does not have a translation component. So I'll just put a W of 0, and that's it. That's all that the W does. I'm using it to construct vec4s, so the mat4 can be applied to it. Okay. I'm going to try to do this as a one-liner. So I'm going to take my pre-transform, multiply it by a vec4. Now to make that vec4, I'll read in the 3 numbers that I would normally have. Okay, so we have our x, y, and z. Then we have our w component on there, just like that. I think that line's getting a little long. Anyway, too much nasal, nasal? Too much navel gazing. That's hard to say, navel gazing. Okay, so again, to step through it, what I'm doing is applying this transformation matrix to the stuff, and then casting that back to a vec3. In the case of a position, we potentially want translations, we'll set a 1 there for the fourth component. In the case of a normal, just rotations, we'll set a 0. Enough talking, let's give this a shot. It's been a surprising lack of errors today. It's making me nervous. Ah, perfect, there we go. So the camera is here at the origin, we have the cube, and then behind the cube is the girl. I said the girl was meant to be facing 180 degrees rotation, so facing towards me, because I'm looking down the x-axis right now. And yeah. There we have it. Very cool, very cool. Anyway, I hope you enjoyed this session. Did you have fun? I had fun. Apart from that screenshot thing, I don't know. Oh, geez, I don't know what's going on there. Anyway, that'll be it. I really do hope you had fun, and I'll see you again soon. All right, bye.